Hi, this is part E of question 1 on Math 2017. So this question we're told that a and b are positive integers such that a plus b equals 20. And we want to know the maximum value that a squared b can be. Okay, so I'm going to call the thing we want to maximize y. And often when we want to maximize or minimize something, we will differentiate and then set that derivative to 0. But we can't just simply differentiate y because it's in terms of two different variables. So what are we going to do now? Well, we'd like to be able to get rid of one of these variables, write it in terms of the other one, because then it will all be in terms of one variable and we'd be able to differentiate. And they've given us this piece of information which we're going to use to do that. Okay, so say we write b in terms of a. Rearranging this for b will give us that b is equal to 20 minus a. And then putting this in for b in y will give us that y is a squared times 20 minus a, and I'll just expand out so it's easier to differentiate later. Okay, so now if we differentiate with respect to a, then the derivative is equal to 40a minus 3a squared, and setting this equal to 0 to find the stationary points gives that 40a minus 3a squared is equal to 0, or that a is 0 or a is 40 over 3. Okay, so let's have a think about what y is going to look like. So it's a cubic, and there's a minus in front of the cubed term, so its graph will look something like this, and we know the stationary points are at 0 and 40 over 3. So we can see the maximum is at 40 over 3, a equal to 40 over 3. But remember that a and b are positive integers, so all the negative values of a over here don't matter. And we're not going to be able to use 40 over 3 exactly. We'll have to find the integer value of a, which will give us the biggest one. So 40 over 3 is equal to 13 and a third. So we see that it is between 13 and 14. And because it's decreasing everywhere else that we care about, we can see that either 13 or 14 is going to give us the maximum. And now 13 and a third is closer to 13 than 14, so you can probably guess that the maximum is going to occur at a equal to 13. So if we work out what y is when a is 13, if we just substitute a equal to 13 in here, see that this is what we get, and that's the same as 13 squared times 7, which when you work it out is 1183. And if you wanted to double check for 14 as well, you see that it's equal to 1176, which is less. So the maximum value is when a is 13, and then we get that a squared b is equal to 1183, so that's answer D.